Awesome stuff. Hello, hello. Oh man, that's so cool. All right. I hate that this is set up in this corner. I'm gonna have to move it. Some better light. All right, here we go. That's just one. It's got two drives, so that's just one drive. I put both of them on, but I think I took my finger off. All right, so there's no real good way to stop it currently. So, hello, hello. What's going on, Tommy? That's cool, man. You cut the power right off so it doesn't burn everything up. Oh, that's so neat. It's so like controllable too. It's like just stopping it altogether is kind of hard. Here we go. Yep. That's going to take my finger off. See how much torque that had? That's amazing. Woo! All right, so wow. Yeah, all right, you're right. Don't break it. Yeah, you gotta be gentle with it. This, well, this is the base here is that of an utron. So it's a cone, really. That's all it is. Basically, is a cone that its height is half the length of the base. So when you put two of them together, you tilt it to the side, you get a square, and you look at it down the barrel, you get a circle. The only way you get this shape like that is if you go half the length of the base for the height. Yeah, so this is the utron, uh, lower half. It's got 6 magnets in at 120. It's awesome. It's awesome. The electromagnets are at 120, or I mean 180. So they're, you know, and every time it crosses, you get a double whammy. All right, here. Well, I don't want to do that right now. My finger still hurts. We'll just turn one on right now, and you get the counter rotation. All right. I might have done something there. I'm not quite sure what just happened. So that sounds like, yep, the bass just popped out. Let's see if that works. Nope. Well, I can't even see. Let's see if the other one's working. All right. So, yep. We're going to give that a little rest. I know that one's down. These are really easy to make. So, I just need to make sure that the connections are all good. And then it might be the transistors blown. Yeah, that's pretty sweet, don't you think? That's really cool. And then just make sure it's off. And then fixing this, if it's broken, is not hard. It's really easy to do. Just take it over someplace with some light. Make sure it's all hooked up. This is an electromagnetic rotor. So the drive coils are on the rotor. Yeah. And then this is the stator, but the stator can spin, so that's kind of awesome. And then it's maglev on the stator, which is an utron, by the way. Let me try this. Yes, I fixed it. But now I gotta glue everything back down again. Okay. Maybe I didn't. Hold on. Oh yeah, yeah, that's good. It's good. It was just a loose connection. I was never really worried though. Yeah, the problem is that the print took 3.5 days to do on silent mode. So they could get like a perfect print, and then it still screwed up the center hole on this part. So it's really tight on the pole right now. It's like extremely tight. Neodymium magnets. They're N52s, and they're, let me see, 40 millimeters by 20 millimeters square. I don't know. What do you mean? How did I make them? I'm good, dude. I'm good where I'm at. Probably been here longer than you. Yeah, they're pretty strong. There's the circuit right there. There's 2 of these inside of that rotor. Yeah, I wired them up. You got your battery, you got your MPN, you got your light bulb, and you got your coil. And you got 2 of these in there, and it's powerful. And it counter rotates. So if I spin this, if I spin the stator clockwise and I spin the rotor will spin counterclockwise regardless of whether I spin it that way or not. It does it automatically. What is it called? We're gonna call it, I like calling them the counter rotating pulse motors, because I build them like this, like all up and down, man. I build them with commutator plates. I build them. Here, let me show you. This is the part of my first one that I built. I got a video showing this one working at like with 60 volts going through it. Counter rotator, awesome. And you do it with maglevs. You do it with see, like the rotor in here has a magnet in here, and then there's one inside this. Fits right in there. I built the whole, it's perfect, you know, like it belongs there or something. So it's just like floating in there. So it can spin really good and allows for the outside to spin the other way or at all. You know, it's awesome. All right, you want me to turn it on? Does anybody want me to turn it on? That's one engine. I forgot to glue the stuff down. Or no, I didn't. Did I? No, I don't think I did. I thought I saw something flying. All right. But if I had both engines on, that would get it going that much faster. All right, I'm going to try spinning the outside to get it going on the inside. Here, let's try that. Bingo. And when you stop it, the inside will get going that much faster because now the magnets are stationary and any timing that was off is now not off anymore. But at the same time, there's like every so often when it's spinning the opposite direction, you get a propagation of speed. So it'll go, that much faster with it going counterclockwise, or I mean, counter rotator. But I do believe that when you hold it steady, it goes faster. I might be wrong. I mean, they go really fast both ways. Thank you. I appreciate that. And this is the circuit right here. You got your battery, you got your NPN, you got your coil, which is a bifilar coil, 28 gauge. It's 5.3 ounces or 200 turns of both of those. And that's that. That's a complete circuit right there. My bad. That is like the most simple, effective circuit you can make. And I used 120 halogen bulbs instead of the 90 volt neon bulbs. They both work really, really good because they're both the filament type light bulbs. But I don't know. I think like for the pulse motor thing, the neon bulbs might be a little better. But for this circuit, because as you can see, there's no way to get, the readings off here. I have two pickup coils on here that I haven't hooked up yet. But when I get those hooked up, this thing should be able to feed itself a little bit of energy per circuit, per turn, per revolution, whatever you want to call it. Probably not enough to do like the 12 volt battery, but there'll be enough there to elongate the spinach. So I gotta hook those up. And what I'm gonna hook them up into, here, let me grab that real quick because it's really cool. So this little apparatus right here takes the energy from the series pickup coils and shoves them in the AC end of this thing. And then it comes out rectified, purified DC, usable DC. And the cool thing about these is you can have the pickup coils and the battery juice flow through this, and then just need to hook up these two ends, and that energy will be combined in here. Because see, these are the parameters right here. Max AC equals, what does that say? 50 volts times 2. Max amps 6 amps times 2. And the output is 600 watts per side, so that's 1200 watts. Awesome, man. This thing handles a lot of power. It really does. It looks tiny, but it's does the trick. No, I use copper. Hello, hello. Yeah. Okay. That was my bad. Oh, wow, dude. I'm glad I got spare components. But I got to remember which way the center is going. I got to remember which way this is spinning, or that's going to happen a lot. Well, it probably won't happen that much more. I mean, honestly, that's no fun. But yeah, man, it's really cool, but it needs a little bit of work before I can start using it. Like I need a commutator ring on the bottom here. See, when it gets going that fast, I couldn't tell which way it was going, and then when I stuck my finger in there to stop it, um, it was obviously going the opposite, the wrong, the other way. And so when it just kind of hit that. And actually, it was my wrist like this, and it caught all that stuff up there. Yeah, it's okay though. It's all right. So, yeah, I'm gonna hook that up. Probably not gonna be doing too much. I'll hook this in there too. I'll get the pickup coils going, and I gotta figure out some way to be able to stop it. You know what I mean? Like maybe I'll just put my hammer in there like this. But currently, I don't even know. That might be it on the ground there. Where my MPN went, the breadboard's right here. I know I broke the light, but I got a lot. I got replacement lights. I got a replacement MPN. And that's pretty much all I need. because the battery's in there. And then I was even messing around with this. Put one of these in there, like turn it on to a certain pulse, and then just have it hooked up and put it in there. You mean like capacitors? You mean like capacitors though, right? Have a reverse set of capacitors pump into your coils to slow it down. This is PLA. And it took, it was a 3-day print, maybe a 4-day print. It's crazy. I did it on super slow-mo, and the center hole's not straight. The hole down the center here is not straight. So you can see that it's very lopsided. But it doesn't matter. See, it's just good enough. It's for government work. I'm gonna print another one, but I'm gonna make sure, I might even make it a little smaller than this one. But the rotor is like awesome, Wow. See, now I've got a place for a magnet on the bottom of this, but I don't need it. Oh, there we go. Maybe I do now. All right. That's cool. Let's maglev this thing. All right. So that's got to go facing down. Up. Oh no. Man. Dang it. Is there a way? It's so close, man. Oh, this thing is just. Maybe there's something caught. No. Nope. Damn. It's so freaking close, man. It's like, it's because it's a 0.4 millimeter nozzle, I'm thinking, and I didn't give it the clearance, the 0.03 that it needed, because I'm used to using a 2 millimeter nozzle. Damn. It's all right though. Because it works without it. So frustrating sometimes. You know what I might do? Is I might have a company print it for me. I know it's going to cost me a pretty penny, but the center hole will probably line up straight. It'll be a much more even print. Man. Oh, dude. Well, I know what I got to do for the next one. Got to make this nubby a little bit thinner. And then whoever prints it or whatever printer prints it, that's fine. But there's a few little technical things that I got to take care of. Yes. Oh, you got the toroid, the ferrite toroid magnet in the middle here for a maglev for the rotor. And I was going to put this one on the bottom here, but it won't fit. By like less than a millimeter, it won't fit. Like if I won't hammer on there by that much. Sucks. It sucked. I was like, dang it. But I like how it spins without it too. You know, it's not that bad. I'm gonna fix it so it works, but that spins pretty good, I think. And this is the electromagnetic rotor. And it's maglev in the center of the utron, like so. Hi.
Hi.
And when everything's glued down and put in here, and this thing can go really, really fast. All right. Well, I just wanted to give a quick demonstration, and I broke it. So I'm just going to show you that it goes in here.
Broke it on the first day of working.
Oh yeah, yeah. But it's all right because it's right here. I got all the pieces. I just need to have the time to put it back together.
Okay.
But I think there's one circuit on there that's working, but everything's kind of hanging off the edge. Just, I'm telling you, man, it's really neat. Uh-oh.
I'll spin it. This one?
No, you can't spin it.
You can't?
No, you can spin that though. There's too much stuff hanging off the side of this thing to spin it. Yeah, I might build another rotor too.
You know.
There's no maglev on this, but I use toroid magnets for maglev.
Can you spin it?
Can I spin it?
Yeah.
Yeah, these are the supports that I don't even know, man. I came out all crooked and everything, but it made it work really, really well.
Yeah. So when I first looked at it, it kind of looked like underwater, because this kind of looks like the decoration,
Mm-hmm.
like the kelp.
Yeah. I mean, this thing was so powerful that there wasn't any way to like stop it really. I mean, you can't like, you can have there be like a braking mechanism, but there's no way to turn it on and off. Okay, so like when you want it to be off, you can't do that. And there's no way to turn off the power to make that change happen without stopping it. So I don't know.
I'll be right back.
I already told you, man. I said I was using these toroid donut magnets. What are you doing over there? With all the question marks and everything, you missed me explaining it. Tinfoil?
Yeah.
For this?
Yeah, I'm gonna put.
All right. Yeah, I wish you would have came in here earlier, man. And you gotta put the shiny side up.
And there's still some pieces left on here that won't get off. There's a piece that was on the printer,
Mm-hmm.
and there's a lot of stuff on there, but they're really.
All right, you're gonna see how fast we can spin this by hand or what?
Yeah, let's see. Can. You spin this really fast last night.
81. Wow. Nope, 156. All right. You know what? I'm gonna start gluing this back together real quick.
We got a printer. We got everything. Got a piece off.
Let me just count there. 1, 2, 3. Looks good. Let me make sure.
I didn't know you had this back here.
Mm-hmm. My Tesla coil?
Yeah.
Yeah. I'm just going to remove any remnants. Gather all those jumper cables up.
Works. Oh, that's going way too fast.
Woo yeah. Back in business.
Yeah. So if I put the switch, it's going to go like ridiculously fast.
Mm-hmm. Now I'm going to spin the stator counterclockwise.
Oh my god.
Whoops.
Okay.
And the rotor goes clockwise. It's awesome. Yeah, okay, good. You want to try?
Yeah.
All right.
What do we... Should I spin it?
Nope. Spin the middle part. Yeah, don't touch the switch. Yeah, yep. Use the coil. You want to spin it that way. No. We're not going to do it. Don't do it. Just spin it the middle, spin it this way. It's easier for me to stop it then.
Alright.
Like that. You gotta turn it around though. Yeah.
I'm gonna actually do it this time.
Oh yeah. Look at that, man. That's like in unison, but it's like I'm so like I want to be mad about it, but I'm not. I'm not because this works so well. I'm gonna make a better one, but
I'm gonna actually move.
okay.
I'm gonna get a better view.
All right, ready?
Yeah.
and then it's up high on the pole. It's like a 2.5 foot pole, and it's all the way up on the top. So it's like, that's another wobbly effect.
I've been in here for like 13 minutes.
You've been in here for 13 minutes? Alright.
When I grab the tin foil, that takes up like 30 seconds.
And just to give you a gander at the power involved here, yeah, I don't know, they're really powerful. Torque involved with these little coils is awesome. It's gonna be cool.
This is cool. Right here. Cool one. And it's a little tiny.
See, and it's like pushing my hand around. All right.
I wanna like have this.
And I encourage people to like go out and do stuff if you can. Build things. Some people can't build something unless they know what its purpose is already. I don't even know about that, man. I mean, the only thing this does right now is spin and counter spin. That's all it does right now. I got to make a commutator plate to get any readings off of this. And they got to have brushes hanging down and all that good stuff to get readings off of this. Unless you put a meter, hook it up to the system and have it inside the rotor and have it save data. And if you get one of those, you can do that. I've been struggling with being able to like get readings off of this, so I just said, screw it. I don't need to know what the readings are. Who cares? Just to get the readings, you're slowing it down. It's like, let it go. Let her buck. Forget the readings. But, you know, and then there's that part of me that says, no, you can't do that. There's obviously something's going on here. We should figure out what it is.
I'm gonna try to put out this on.
So let me show you the circuit.
There we go.
You got, well, there's one of these in there now. You had two in there, and I broke one.
These are like. I don't like this one. This one's real tiny. It's tiny and perfect.
So you get these pickup coils in here. You're gonna feed into this cap bank, and the cap bank's gonna be resting in here like so. Like that. Then the battery juice, the cap bank, the battery juice and the pickup coils all filter through this cap bank. Yeah, man, it's gonna be awesome.
Got that done.
So what I like to do is for each coil, you get your 1 and your 2 connections. So you get your end and your start and your end connected to 1 and 2. twice. So you do each connection in parallel to this cat bank and your batteries. It's all, each gets its own connection. Unless these are going to be in series, in that case you get the start of one and the end of another. No, no. Get that off. All right.
I'm gonna. I don't want to do it too hard because it might break my finger.
Yeah.
Because there's just like the magnets right there, and the corners are really sharp. So I don't want to get caught in my finger.
So all right. So this is the general idea. The next one I'm going to build is probably going to be a 12-inch. This is 14. I'm going to make it a 12-inch utron with a nubby that has enough space to put one of these around it. It's just too big. It's like just too big. Sucks.
You got a really small cone.
Ha.
Yeah, I don't like when that goes fast. Like it really fast.
There we go. You don't like it?
I don't like when it goes fast because I remember when you said the magnet full cost everyone, and I kind of don't want that to happen.
There's no magnets really moving. That's the cool part about this. The magnets aren't moving very fast, is what I'm saying. But you're right, you know, if they do ever get going pretty fast, they probably could. I mean, they're in here really tight. Explain to me how that'll work. You mean to slow it down permanently?
I mean, we do have.
I'm all for it. I just want to know how the mechanism works. I understand how it works on a bike, but how would it work on this?
I mean, you can, and I mean, I can explain. Like something like you said. I'm just dreaming about Dad can put like something like that, but it connects to my wheels and my bike can go like really fast.
An electric bike.
Yeah, that would be cool.
Yeah.
I'm gonna get a bike for Christmas, which I might get.
I'm not looking to like slow it down. I'm looking to like make it stop when I want it to stop.
So like there would be a switch on the handlebar, and then when I want me to pedal it, I can just flip the switch, and it will stop. The motor would stop. I always wanted that to happen.
Yeah, I don't know about I granted we can slow it down, but is that really the ultimate goal, to slow it down? I don't want to slow it down. I want it to have, like, if it's gonna have braking, it's gotta be braking that's gonna, like, it's all gotta be remote controlled, or it doesn't work.
I think
You gotta be able to turn it on and off. It has to work that way.
I think you always wanted it to go fast, but not like really fast.
I've been looking into wireless, control, remote control. But even with wireless stuff today, you have to turn something on the unit. There's a switch or something and batteries in it. And that's cool, man. All I need is like a receiver. That's what I need.
I think there's always an on and off thing when it comes to a battery, but not like a battery, like just the battery itself, like this. At school in science, we had to hook up a light to a battery, and we had to flip the switch, and the light will turn on. But we gotta use like, something like the end of this battery. Something like the end of this battery, and you put the wire inside it, and then we used a D battery. We used like a D battery, and then we would hook it up to a red thing, and the electricity would go to the light, causing it to light up.
Mm. Well, all in all, I think it's a victory. I consider this a victory.
I mean, it's been like 3 days since you have it printing on there. It's been 3 days since you.
To have a stator that moves, that's awesome. Mm. Well, I'm pretty tired. How about you?
I'm also tired, but I'm gonna play on the VR one more time, and I'm probably gonna. I always play on the VR tonight. I play on like the VR like 5 times tonight, maybe more, because I want to play on it a lot, but I just. So the VR would die, I would charge it again. The VR would die, I would charge it again. The VR would die, I would charge it again. Something like that. That actually did happen.
Woo!
Every single time it goes fast in my mind, I'm like, this thing can hit me.
Hello, welcome in.
This thing can hit me, and I could probably end up in the hospital.
What, this thing?
Yeah.
No.
Maybe it can like fly up.
No. No. You're all right. I wouldn't worry about it. I just love how they interact with one another. Now they like to spin the other way, the opposite direction.
I'm probably gonna go now.
Okay.
I've been in here for 30 minutes. I got here in a little bit. And on 42 minutes. I'm gonna go now.
Alright, see you later.
See you later.
There's my son. You can just imagine how powerful this thing would be if two of them were going at the same time. Wow. All right. This is a counter-rotating pulse motor built in the base of an utron. Awesome. Woo! All right. There's a circuit. It's going real fast when you stop it. Oh wow, I'm so satisfied. Even though it's wobbly, it's a little wobbly. Awesome. Yeah, I don't know. I'd say this is the first good step, though. Step in the right direction. We do need a way to slow it down on command. Maybe, yeah, maybe we could use a bicycle brake, at least on the outside. Like have like a brake pedal, and then you push back on it, and then clamp down and slow it down. I think that would work. Have it like on the base of the utron. Oh no, man, we need it on the rotor. I don't know if it'll work like that. Yeah, it would work on the utron, but the shell is the utron, where the neos are. All the electromagnetism's on the rotor. Huh. Yep. All right. Yeah, maybe a drum brake. Yeah. All right, ladies and gentlemen, I've had about enough for tonight. I'll be back later. Um, we can go through more ideas, but like the bike drum brake sounds like it might be a good idea. But I'm about to pass out. It's like, yeah, I gotta sit down. All right. Well, thank you very much. Really appreciate everybody chilling. This is really exciting for me. I've been dying to make one of these like this for a long time. All right. Peace out.